Suppose you're just walking down the street and somebody jumps up and he wants you to solve his equation for him. X squared minus 5x plus 3 is equal to 0. In this case, what would you do? We know we don't have to worry, right? Because we can just use the quadratic formula or completing a square to solve this quadratic equation. Yes, but unfortunately, he changes his mind to x to the third power. But let me tell you, we still don't have to be worried because we do have a cubic formula to solve a cubic equation like this. Even though the cubic formula is bigger than the quadratic formula, but it's still pretty manageable. And you know, yeah, he decided to change to x to the fourth power. And let me tell you, we still don't have to worry because we do have a formula for a quadratic equation like this, meaning a polynomial equation with degree 4. But I would not recommend you guys to look that formula up because the formula is pretty scary. So yeah, don't do that. And finally, you know it, we got him so mad. So he changed it again to x to the fifth power. Do we have a formula for this? I will have to tell you, unfortunately, we do not have a formula to solve any quintic equation, meaning a polynomial with degree 5. In fact, whenever we have a polynomial with degree 5 or higher, we do not have a general formula to solve that equation. So, what do we do? Well, as you guys saw over there already, Newton is going to come up and help us out. Newton's method. The purpose of that is, let me just write that down right here, to get a good approximation for the equation f of x is equal to 0. And then of course, let's see how this will help us out, and then we'll solve this later on. So here's the deal. Let's derive the formula first. And to do so, we will have to look at a graph. Let's say we have a function that looks like this. And I'll just say y is equal to f of x. And we see that we do have two solutions right here, and maybe another one here, but let's not talk about that. This right here, if it's at 0, that's easy because you can just guess x equal to 0 and plug in. If you end up with 0, done deal. But for this one, not so much. So what do? We still can guess, and hopefully it's a good guess. And let's say my initial guess is right here, and I'm going to label it as x1. Some people will label it as x0, but same thing. And what we can do next is that, well, just remember what we can do in Calc 1. In Calc 1, the most important thing is just take the derivative, take the derivative, take the derivative, take the derivative, take the derivative. And the purpose is we want to make curves linear. Right? We talk about equation of the tangent line a lot. So this is another way to use equation of tangent lines. So we have x1. Let's go up here. Okay, and then we have the point. You see that this is so far above 0. But it's okay, because now let's just go ahead and draw a tangent line. So let's see, we have it like this. Good. You know why? Because you see that this is tangent line, and we can find the x-intercept of the tangent line right here. And this point is actually closer to the actual solution that we want. Remember, this right here is our goal. This is closer to the actual answer that we want than our initial guess. So, right now, let's try to figure out how the process will work. And the first thing that we need is the equation for the tangent line. And to do so, well, we need to have two things. The first thing is the slope, and the slope is just the derivative. So I will just say differentiate that, just keep that in mind. And the second thing is the point. Here we have x1. You can just plug in here, and then you will just get either y1, but we can just use x1 here and put it here. So that will be denoted by f of x1. So that's the point. Cool. So now I'm just going to write this down for you guys. We are going to use y minus y1, which is this right here. So that's f of x1. And then that's equal to the slope. And again, the slope is just the derivative. So I'm just going to put down f prime at x1. And then we have to multiply by x minus x1. And this is just the what? point slope form of the line. Good. And then we want to have the x-intercept here, meaning that the y should be equal to 0. So I'm going to put down the 0 right here. And guess what? Earlier our initial guess is x1. This right here, let's just treat it as a new guess. I'm just going to say that's x2. So I'm going to label that as x2. So we put 0 for y, and then we are going to put x2 right here for this x. And we can see we have the rest. It's just that, and then minus f of x1 equals f prime of x1 times x2 minus x1. And let's see how x2 looks like. And to do so, we can divide this on both sides. But let me write it down this first, which is x2 minus x1. And that's equal to this on the top, which is negative f of x1 divided by the derivative at x1. Cool. And I'm just going to move the x1 to the other side, right? So that becomes positive. And ladies and gentlemen, x2 equals x1 minus, and then we have f of x1 over the derivative over there. So f prime of x1. Yeah. Well, x2 is better than x1, right? Supposedly. Let's just not be lazy. Let's do it again. Take this as our guess, go up, okay, and then draw the tangent line. So it will look like this. It's a tangent line, okay, just trust me. Maybe better, maybe worse, I don't know. And then we see that this right here, we can do the same thing, meaning we are going to find the green dot, the x-intercept of the red tangent line. And of course, we can say that's x3. And what's x3? Well, x3, we can just repeat the same thing. And that's just going to be treating x2 as our guess. So we will just get x2 minus, of course, repeat the same thing. You just replace the x1 with x2. So you have x2 minus f of x2 over f prime of x2. And so on, so on, so on. And of course, the more you do, the better that gets. And it will be a super challenging, somewhat like that. Yeah. Okay, so I'm going to just write down the formula right here for you guys. And ladies and gentlemen, this is the formula for the Newton's method. In general, we want to have an iteration, meaning that if this process works, then just do it as many times as we need to get the better approximation as possible. We will write this as xn. And then this right here, it's equal to, you see that it's a previous x value, so that the notation is xn minus 1. And then minus the value of the function at that previous x value. So we will have f of xn minus 1 divided by the derivative there. So f prime of xn minus 1. And this right here is the formula for the Newton's method. It looks so wonderful because with this, it looks like we can solve any equation that we want. Well, we have to be super careful with the initial guess. First off, the initial guess cannot be way too far off, right? Or it cannot be on the other side, because if we put x1 to be right here, most likely it's going to suck into this solution rather than that. So that's one thing. And the other thing is that if you look at this formula, we have the derivative on the bottom. We will have to make sure the bottom is not equal to 0, meaning that the derivative cannot be equal to 0. As we can see, the derivative right here is equal to 0 because it's horizontal. Imagine if you draw the tangent line, you get a horizontal line. A horizontal line will never cross the x-axis. So you really have to make sure that, I'll just put this down right here, we have to make sure our derivative at any guess is not equal to 0. Right, that's the biggest thing. Right? And of course, sometimes there are technicality, because again, if you put your initial guess right here, then you are going to get this solution, and then you cannot get to that one. But that might be a discussion for the other one, for another video. Because right now, I would like to show you guys how we can solve that question that I gave you guys earlier. So that guy on the street, huh? We want to solve the equation x to the 5th power minus 5x. And remember, minus 5x plus 3 is equal to 0. The truth is, there are 3 solutions. I'm just telling you guys that. I'm going to just find one of them for you guys, and then you guys can try to find the other 2. Okay? So, first off, the way that we can use Newton's method is that we have this equation equals 0 already. So we can just say this right here is our function, and let's just go ahead and do that. Let f of x be x to the 5th power minus 5x plus 3, and then do the derivative f prime of x, and we need a derivative, so do the derivative 5x to the 4th power, right, the power rule, and then minus 5. Good, so these are the ingredients. Now, we need to have a good guess. How can we do it? Well, this right here is just a polynomial equation, so we know that this polynomial function is always continuous. So if we can find out an interval where the endpoints change signs, meaning one is negative, the other one is positive, then we can argue with the intermediate value theorem that we must have a solution, at least one solution, on that interval. So we look at this and just kind of guess, I would say. Notice the following. When we have f of 1, if we put in 1 into here, we get 1 to the 5th power minus 5 times 1, and then plus 3. What's this? This is negative 4 plus 1. Sorry, negative 4 plus 3 is negative 1, which is less than 0. Okay. And then if we do f of 2, this right here is 2 to the 5th power minus 5 times 2, and then plus 3. That's 32. That's 35 minus 10, which is 25, and it's greater than 0. So as you can see, this right here is below the x-axis, and then this right here is above the x-axis. So in between of x is equal to 1, x equal to 2, we must cross the x-axis somewhere at this one time. So I will just say, by intermediate value theorem, there must exist, that's the notation for there must exist, a solution, and when we say a solution, it means at least one solution on the interval 1, 2. And some people will put on bracket like this to make it look like an interval. Some people will use the parentheses because at the endpoints you know it's not solutions. But let me just use the bracket because it looks more like an interval. Yeah. But anyway, oh, I should also say this right here is continuous in order for us to be legitimate and say that by intermediate value theorem. Okay, so now what would be a good guess? 1? Everybody likes 1, huh? No, 1 is not a good guess. Why? Because if you put 1 into the derivative, if I put 1 into the derivative, I will just write this down for you guys. F prime of 1. This right here is 5 times 1 to the 4th power minus 5, which is equal to 0. Guess what? This 0 is a sad face. We don't want that. So 1 is not a good guess. 1 is not a good guess. So what do we do? Well, let's use 2 then, I guess. Well, 1.5. Yeah, somewhat like that, right? So I'm just going to say, let's put on this right here. I am going to use black right here. I'm going to take my initial guess, x1 to be 2. All right? And then now we'll just have to apply the formula. So, ready? Cool. x1 is 2. To get the next x value, and that's going to be x2, that's going to be plugging 2 into here, which is just the previous x value, and then plugging 2 into the function. So we will just have the 2 right here, and we will have to subtract. And I'm going to write down the whole thing for you guys at least one time right here. So here we will just get 2 to the 5th power minus 5 times 2, and then plus 3. And then over plugging 2 into the derivative, which is 5 times 2 to the fourth power and then minus 5. So that will be x2. How do we do it? Well, technically, we can do it by hand. It's not so bad because this is just addition, subtraction, multiplication, and power. Everything is doable if we have patience. But I have a calculator on the side, a computer. I will tell you, this right here is approximately 1.66. Repeating, so I'm just going to put down, let's say, 1, 2, 3, 4, 5, and then I'm just going to round up. Yeah, so 1, 2, 3, 4, 5, 6 numbers. All right, and then we can just repeat x3, and for x3, if you want to show work, you can just write down the following. This right here is equal to whatever this is, which is 1.12345 and then 7. You see what I did over there? And then do all the rest. So minus 1.12345 7 to the fifth power minus 5. 1.66666. Wait, 1, 2, 3, 4, 5, 6, 7, and then plus 3 over all that stuff. 5 times 1.6, 1, 2, 3, 4, 5, 6, 7 to the fourth power and then minus 5. Yeah, so that will be the computation that you do, all right? But you know, I'm not going to do all that anymore. I will just tell you, x3, it's approximately 1.4425, right? I'm just going to write down this many digits that don't have enough space, so excuse me on that. And then we just continue. x4, it's going to be approximately 1.3204. All right, and then x5, and then I'm wrong now, by the way. x5 is going to be 1.28. Yeah, this right here converges, meaning that it goes to the actual answer a little bit slowly. Let's see, 28, 0, 0. And then x6 is approximately. Why are we keep going? The reason is because we see these numbers are still quite different. So that's why we keep going. If you see the numbers, they are about to become the same, then we can stop because they are approaching to the solution. But anyway, this is what we had earlier, and then x6 is 1.2757. All right, so at least now we have the two match, and then now x7 is approximately. Oh, look at this. We have 1.27568. 568. But of course, if you round up, that will also be 7. And then if you keep on going, you'll just get the first few digits being 1.2757 and so on, so on, so on. So I will just tell you guys a solution will be this. This will be a very good solution for this equation. Alright, so hopefully this right here makes the Newton's method clear, and next time somebody does approach you and if the person, he or she wants you to solve their equation for them, yeah, Newton's method is the way to go. Of course, here's the deal. How do we find out the other ones? Here's the thing. Okay? Right here, I use x1 being 2. And then we get this for the answer, right? 1.27 each. If I started with x1 is equal to 1, it's no go. Don't draw sad face on your tests, right? It's just bad. Go ahead and do this on your own, right? So the question for you guys is, if you take x1 to be 0, let me know what the answer is, right? Let me know what the answer is. You may be surprised. And then once you have that, try to find the third one, because once you do this, you will get the second solution, but there's also the third one, and for the third one, you will have to put everything together and then really think about it. If you want to learn more calculus, then one good place for you to start is our sponsor today, Brilliant. It is an excellent online learning platform with a big focus on interactive learning. As we can see, this is from their Calculus in a Nutshell course. This course uses visual and physical intuition to present the major topics of calculus, namely limits, derivatives, integrals, and infinite series. You will walk away with a clear sense of what calculus is and what it can do. I can tell you that taking a course from Brilliant is really fun because they will always keep you engaged by storytelling and beautiful animations. Besides calculus, they also have other courses in math, science, and computer science, so you have a lot of choices to choose from. And I have a special link for you guys. Use the link in the description, brilliant.org/blackpenredpen, because that way you can get 20% off discount. I want to thank Brilliant for sponsoring this video. I also want to thank you guys for checking them out.